Thank you, everybody, for coming. I need a photo, so you guys I just need you to say open source. Now, can you just say that before we take a photo? 1, 2.
Open source.
Oh, that's so good. That's so money. Thank you. So good. Now then, this is the amazing, the without parallel, the incredible Dr. Syer. He's paying attention to the code, not to us. That's why we like him. And I'm Josh. My name is Josh Long. Dr. Syer, I'm going to call him Dr. Cloud Native. You want to tell us about yourself, Doc?
You can read, right?
He's one of the contributors to Spring, the co-founder of Spring Batch, co-founder of Spring Security OAuth, Spring Boot, and Spring Cloud. Basically, he gets what we're trying to do here, and then he tells us what we're trying to do.
I'm a Spring guy. I've
Yeah.
done some Spring.
So thank you for joining me today, Doc. He's going to make sure I don't screw this up.
My role here is to slow him down if at all possible, right?
Right.
So I might need some help. If anybody has a question, you know.
Yeah, don't hesitate, please. I am, well, this is an old, irrelevant slide now. The slide is out of date. It's a lie. I am not the definitive article, it's an indefinitive article, a Spring Developer Advocate at Pivotal. That's my email and my Twitter. How many of you are on the Twitters? It's 2015. How many of you are on Twitters? Twitters? No one? No one. Nobody. Awkward. Okay. Okay. It's okay. Well, there's this thing, my friends. Twitters. If you're there, let's carry the discussion forward. No doubt you're going to leave this room upset and perturbed, and you're going to want to vent that. Find me on the Twitters, and we'll talk. We'll talk it out. We'll hug it out. I'm a Java champion and an open source. I'm the leading contributor of bugs to many fine Spring projects, not the least of which are Spring Boot, Spring Cloud, Spring Integration, and so on. And I have a special guest, because you see, we have a special guest. You see, the economics of building applications today, they're very different from what they were 15 years ago when, or 13 years ago when Spring started on this adventure. But yet, some things remain eternally true. So I was hoping to invite Dr. Rod Johnson onto the stage to speak about that for just a minute or 5 or whatever you want, really. Welcome, sir.
Thanks, Josh.
Thank you, sir. Oh, okay, why is it?
Works better when it goes on. So this is actually the first time that I've spoken to Spring One for 5 years. So it's an interesting experience, and it's great to see, I think, the largest number of attendees ever, and also see a lot of old friends in the Spring community. So as Josh says, Spring goes back a long way. Yesterday, I was walking around Washington with my old friend Jürgen Hurler, who, of course, as I hope everyone knows, is a legendary coder, and I don't use that word lightly. A legendary coder, and you know, the heart and soul of Spring Framework, and has been for something like 12, 13 years. So Jürgen and I were walking around Washington, and a couple of things that happened was that I got quite sunburned. Jürgen got a little bit sunburnt, but I always burn more than anybody else. But also, we were kind of reflecting on the last 13 years and how things have changed. So when Spring, the first code that went into Spring was published, it was of course published in my first book as, at that point, the Interface 21 framework. It was even pre-open source. So just think about that for a moment, the world of 2002. So in Washington, you can't avoid thinking about politics. President Bush was early in his first term. I don't think it had really occurred to anybody that the next Republican president would probably be Donald Trump. And in the technology world, things were very, very different. So at that point, I initially conceived Spring to deal with the truly horrible complexity of things like EJB2, you know, early WebLogic, WebSphere, these heavy monolithic application servers that really were designed without the slightest thought about whether developers would actually enjoy life, whether developers could actually get anything done. And I mean, this was already EJB2. EJB1 was so bad that even I don't remember it. But EJB2 was pretty bad. So that was the world where the vision with Spring was to make things simple for developers. You know, to get that complexity, get that boilerplate out of the way so developers could actually implement business logic and deliver business value. So there were really 3 core ideas that Spring was based on. So this slide is one that I actually pulled out of a deck that I have on my laptop. I believe this is from a talk that I gave to AT&T in St. Louis in 2007. And this slide was in our trainings, it was in a whole lot of talks that I and other people gave, and Jürgen just mentioned that he sometimes brings this slide up as well. As you can see, it's not even SpringSource branded. It is Interface 21 branded, which was the original name of the SpringSource entity. So, essentially there were 3 core ideas that Spring was built around. Dependency injection, externalized configuration, AOP, externalize some behaviors like transaction management, a whole bunch of other things, and do it so that it doesn't complicate your code. And finally, portable service abstraction. So for example, if you're going to do transaction management, it's great to have it transparent using AOP, but how is it going to work? How is it going to be guaranteed to work really robustly in every environment? By the way, the answer to that last question is how is it guaranteed to work really robustly is Jürgen Höller, who's in the blue shirt
Thank you, Jürgen.
at the back.
And Dr. Syer.
So, you know, these 3 key ideas to Spring are equally true today. So when we look at the world today, obviously we're not thinking about President Bush, we're thinking about President Trump. And we're in a world where some of those old problems are gone, right? WebLogic, WebSphere, you know, I think that even with IBM and Oracle, they know those products are dead, right? The monolithic app server is history. Even the primary role of things like Tomcat as, you know, really visible things, that's also diminishing because it's all going to be about microservices. It's really the whole notion of the monolithic server is becoming irrelevant. But the interesting thing is, despite all this change, these 3 core ideas behind Spring, and of course a lot of very fine code that implements them, are equally relevant. So for example, when we think about the world of cloud, it's an exciting world, it's all great, it's all shiny and new. Just go and try to use, for example, some of the Netflix and other projects without using Spring Boot and Spring Cloud. And what you'll find is you're writing a whole lot of boilerplate. It won't be that different from things like JNDI lookups that we had to do by hand before Spring existed. So essentially those core ideas are still bearing fruit today, and obviously the very awesome Spring team and the very awesome Spring community are the key people behind that. And it's exciting to me that I think a new string to Spring's bow has been added. So for example, when you look at Spring Boot, there is this original theme of simplification is still there in spades, but there's actually a new approach here. Defaulting, simplifying configuration radically. So, I think it preserves all these key values and adds something else which continues that Spring mission. So, when I look at Spring Boot, Spring Cloud, in particular today, to me it very much seems like continuing the mission. And I guess to pursue the political analogy, since it is inevitable here, the state of the Spring Union is healthy. So with that, I won't take up any more time. I'll hand over to my friends Dave and Josh. Dave, I think I first worked with in maybe 2005.
Yeah.
And he joined Interface 21, I think in 2006.
2007 it wasn't.
2007, was that right?
Somebody set up a bomb to, no, it was 2005, wasn't it?
Yeah.
Somebody set up a bomb, 7/7. Feign.
Oh, that's, yes.
In London.
Yeah, yes. We actually first spent a significant amount of time together in a meeting room which we couldn't leave because Central London was shut down. And I haven't known Josh quite as long, but I'm immensely impressed by his enthusiasm and what he's accomplished in the Spring community.
Thank you, sir.
Thank you, guys.
Thanks, Rod.
Rod? Thank you.
It's really good to hear Rod say that, because
Yeah.
it's kind of as what I felt that when I was writing bits of Spring Boot and Spring Cloud, I was thinking, this must be what it felt like for Rod, at the beginning. It must have been like this, and basically that's what he's saying. We've done the right thing, so thanks, Rod.
Thank you, Rod. Okay. All right. So, moving on a little bit. Dr. Syer and I, we work at Pivotal, right? And we spend a lot of time talking to users, to developers, to customers who are trying to build applications. And we've seen that while they recognize the value of moving to an automated platform to reduce the waste that you find in so-called water scrum fall style houses, where you have agile development being done by the software people, but then you have waste around the edges on the before and after, and it takes time. It increases clock time to deployment. We see customers struggling to get their code out there faster, right? And so we know that in order for them to get their code out there faster and to be able to handle more developers working on their code, there is a threshold, a line that you have to find where it's convenient to write software and then deploy it and evolve it without being gated by synchronization changes from other people, right? There's also scale capacity demands. People are trying to build applications to meet a much larger audience than they were before, thanks to drivers like social and like mobile, right? These things mean that the internet is not just the desktop browser. It means that anybody walking around in their pockets could be a device making lots of requests all the time. We also see that as domains and applications get more complex and more sophisticated, the consistency of the domain, the crispness of the domain starts to blur as you start to add more to the edges. So all of these reasons and more are reasons that people are moving to this microservices model. They have an automatic platform, but they're trying to write software to fully exploit that platform. And that's what microservices gives you. It gives you the ability to write small, singly focused services that work well, that fully exploit this cloud platform. However, distributed computing is not easy, right? And there's pain when you move to this world. And naturally, this is one place where we hope that Spring Cloud, which is built on Spring Boot, can help. Spring Cloud integrates sort of the best-of-breed patterns that the giants of the web have sort of discovered for us with their massive R&D budgets and their massive engineering investment. Now we, the mere mortals, we can take Prometheus from the likes of Netflix and Twitter and so on, and build software the same way that they do, as quickly and agilely as they do. So that's what we're going to talk about today. We're going to talk about these patterns that you're going to need to support when you build a distributed system. I'm going to be coding because Dr. Syer, he wrote all the code over years for Spring Boot and Spring Cloud, along with other very talented people, and then he documented it and made it amazing. But I feel like I'm really doing all the work here. Let's just be clear. No, I'm just kidding. So we're going to go and build a new application. We're going to go to my other favorite place on the web. My other favorite place on the web. Start.spring.io.
What's your first favorite?
What?
What's your first favorite?
Production.
Oh,
Absolutely.
like Disneyland, right?
Yeah, it's better than Disneyland. Much better. You need Wi-Fi for this to work, my friends. So we may be
It's working here. Hey. Nice.
What's the password?
S2GX,
Okay.
if you got the Spring.
Nobody
one.
tells me these things. I just work here. Okay. Am I connectified? Done. Start.spring.io. So if you have a chance, this is an amazing place. I go here all the time. If you're sad and you want something to read that's uplifting, it'll warm your heart, read start.spring.io. If your children are restless and you can't get them to sleep, start.spring.io. If you're uncomfortable, you're having bad dreams, keep it under your pillow. The ultimate comfort. Now, some of you are programmers. I'm a programmer, sort of. I mean, in theory, right? And the elite among us will, of course, eschew a web interface. So we're going to use, we could also use curl start.spring.io because it's far more command line friendly. Isn't that amazing? I think there should be a telnet interface, but nobody listens to me on the Spring team, so whatever, okay? That's one option. I'm also kind of lazy, so we're going to use this. We're going to build a simple domain. It's a microservice called reservation service, like so. Can you see that? There we are, reservation-service. And it's going to be a web application, so I'll build a web application. I'm going to use JPA because I make poor life decisions, okay? So JPA. I'm going to use Spring Data REST repositories to map my application.
Sort of balances the life decision.
Right, yeah, exactly. At least I get something out of this pain. I'm going to use H2 embedded data, the embedded database for in-memory.
Palliative care.
I'm going to use actuator and the remote shell. No, I'm not going to use remote shell. I don't even need actuator, actually. It'll come with it. I also have choices. Naturally, this is a Spring, so you have choices. You can choose, if you are by some fluke of physics, stuck in the distant past, unable to move forward to the future, which, let's face it, is just today, then you can choose WAR. Now, me and you, we're all here today in the same room in 2015, so we're going to choose JAR.
Even though you have a friend, Doctor Who can
Right.
travel in time.
That's true. Darn it.
You still choose JARs.
Of course. This is in keeping with my personal philosophy of make JAR, not WAR. Now, again, whatever your choice, if you can choose what you want, okay? Now, I'm also going to integrate this. We're going to choose, the config client will choose Eureka discovery support. We're going to choose, what else do I need here, Doc?
Service.
Redis, yeah.
Yeah.
I need to choose Spring Boot 1.30 M5 so I can see the new Spring Cloud bits. That's important.
Stuff down there, yeah.
I'm going to choose Spring Cloud Stream Redis. And I'm going to choose Zipkin. And I think that'll do for this. And we'll come back to it in a bit. Okay, so this is our first service. We're going to stand it up. And we're just going to build a simple REST API here. That's the goal here, is just to build something that we can play with. So I'll get rid of all that, hit generate, open this up. And this is just Spring Boot at this point. I mean, I've got some Spring Cloud bits on the class path, but what we're going to demonstrate here is just a basic Spring Boot application. And there are many great talks on Spring Boot here. So, I've made this as big as I can get it. If you need it bigger, you let me know. Okay. Here we go. So I've got a Maven build, pom.xml. I'm going to go ahead and comment out a few things. So right now, I don't want Eureka and the config stuff. So we're just going to leave Spring Cloud Stream bits off, okay? I'm going to build a simple REST API. So I'll say, hello, computer, synchronize. There we go. You got it cached. I'm going to build a simple...
What is that Eclipse you're using there?
I'm going to build a simple domain. I'm going to use a reservation entity. This is a JPA entity. It's a nonsensically simple domain. I don't really want to focus on the domain. We just need to have something to talk to naturally. So I'll say private string reservation name, and I'll say getter, and I'll say I want a constructor. It's going to have an ID, so I'll give it a primary key there. At ID, at generated value. I'll give it a toString method naturally. Okay, I'll give it a constructor. For my object-oriented purposes. I'll give it another constructor for JPA, right? So why JPA? Why, right? And that'll do, right? I now need a way to store that in the database, so I'll use a repository. I'll say interface reservation repository, okay? Extends JPA repository. Now this is just a repository that'll manage entities of type reservation whose primary key is of type long. It's going to have a custom finder method, so I'll say find by reservation name, string, rn, and naturally, I want to expose this over the web, so I'll use Spring Data REST. I'll say REST, repository REST resource. I'm going to map this finder method also to a web service, so I'll say REST resource path equals by name, and I'll map the parameter here to a HTTP parameter, rn, okay? Whew. Good, so that'll do. That should be our first cut. We need some data, so I'll create a simple command line runner. And the command line runner is going to do something very, very simple. It's going to run when the application starts up, and I'll use an injected repository to create some data. Okay, so reservation repository. There we are, and I'll say arrays.aslist, Dr. Rod, Dr. Syer, Yergin, all the community, and then Josh. Okay? Split, hello computer, splitting the data into a record, and I'll write this into the database. I'll say for each record in that list, I'm going to say xrr.save new reservation. Okay? And then I'm going to print out the information that I get back from the client. So I'll say for each system that out. And I'm using Java 8 lambdas, by the way. How many of you are using Java 8 lambdas or Java 8? Oh, okay. Well,
That's a decent number.
it should be a little higher.
Well,
Java 8 is pretty sweet, my friends. You got to do it. The other ones are also end of life, save for security updates. So, give yourself a hug. Java 8, good stuff. Okay, anyway, let's run this. Let's see what we get. We should have a simple REST API using hypermedia, using Spring Data REST, which, of course, the good Dr. Syer so skillfully and usefully demonstrated yesterday. It failed.
it failed.
Because it's running on the same port as another
Something
application.
else.
So I'm going to go here, and I'll curse.
That was intentional, right?
Yeah, that was some, I don't know, 80, 27, I don't care, who cares? Just go. We have something called Zipkin, which is awesome, but it's causing me pain and heartburn.
Adrian's not here yet, right?
No.
We can beat him up later.
So reservations, let's see what we get. No.
It's 80
Oh, 80, 25, is that what we said?
something, yeah.
Sorry. Okay, there we go. So now we have some basic data. Now the goal here is to build a service that takes advantage of some of these things you're going to need. When you move into a distributed systems architecture, the first thing you're going to want is centralized configuration. When we talk about cloud-native applications, we talk about 12-factor app style configuration. The idea that every application should have external to the binary itself the configuration that's needed to move it successfully from one environment to another, passwords, host names, ports, these kinds of locators and credentials. That stuff doesn't belong in the build. And of course, you can use environment variables or -d arguments or what have you. Spring Boot makes it deadly simple. But as you start to scale, you're going to need more. You're going to need centralized configuration. First of all, if I want to change configuration, I want to be able to do so in a single place. If I want to have passwords, then I want to be able to do symmetric encryption and decryption from my password file, which is, after all, on the file system, to the application that uses that password. Again, you need some of the intermediary. If I want to be able to change things live while the system is running, for example, for for feature flags and these sort of things, again, it's nice to have an extra facility in between your properties and the apps that use them. So we're going to turn to the Spring Cloud config server. So start.spring.io, and I'm going to choose Spring Boot 130 M5, and I'll go down here and I'm going to say config server, and I'll tell it to, I think that'll do, just config server.
That's all you need. Yeah.
Okay, and the goal here is I'm going to let config server, which is a REST API on top of a Git-based repository, right? Or a file system repository or Subversion?
Subversion.
As well as Subversion. The idea is that these things are, except for the file system, very good at auditing and rolling back configuration changes. So if something should happen, say that Dr. Syer and I got off stage and then got sloshed to celebrate the delivery of the most amazing talk ever, you don't want us to log into production and make changes without the ability to record what happened and where, and then to roll back, right? So this gives you that facility. So we're going to configure demo application. We're going to say you're a config server, like so, and I'm going to point it to a Git repository, which I just happen to have conveniently laying around on my file system here. So I'm going to say Spring Cloud config server Git URI equals home /desktop/config repo. Okay, so I've got a Git-based repository on my file system there. I'm also going to tell this application to run on port 8888. Okay. We should start this up now. And now the first thing we're going to do is go back and teach our reservation service how to get its configuration information from the config server, right? Again, we want to act as a client to that config server. So I will go here and simply uncomment rather than re-add the Spring Cloud Starter config dependency. This is going to need some information in order to work correctly. So I'm going to tell it, first of all, that its name, it has to identify itself after all, is called reservation-service, and that the config server lives on port 8888. 88 on localhost, right? I could leave the default here, but it's nice to know this. This information, as you can imagine, needs to happen before the rest of the application's configuration is evaluated. It needs to happen in the bootstrap. So what I'm going to do is I'm going to rename this property called application.properties, this file. I'm going to rename it bootstrap.properties. Okay, so hello computer. Refactor. That should have worked, but whatever. Bootstrap.properties. And that's the only configuration we're going to have from one service to another. Again, the goal here is to write as little as possible and get the benefit. We have the config server running here on localhost 8888. And I'm going to show you what the configuration, for example, for the service that identifies itself as reservation service looks like. I'm going to go to reservation service master. And I can see in this JSON string, result rather, that I have two property files, one called reservationservice.properties, which has 3 properties, including a message. And then I have another property file, an application.yaml file, that is more generic. So every microservice will get the configuration in application.yaml or properties. Only the service that identifies itself as reservation service will get the properties in this one. Should there be a conflict, as there is in this case, between server.port in the reservation service and server.port in application.properties, the more specific one will win. Okay, so let's take advantage of this. I'm going to use the message here, this key that's in my config server. It's a REST API sitting in a separate process. I'm going to now configure my Spring Cloud-based microservice, reservation service, to use that message, and we'll demonstrate a few features.
He's not going to stop unless you ask a question, by the way.
You should ask questions if you have them. Class
Just so you know.
REST controller.
He might slow down at the end. He's going to need a little bit of help at the end, I think.
Oh.
This, by the way, if anybody's a student of the cloud native thing and you're not too precious about it, this is really, I think of it as a generalization of environment variables. If that, you could just, easily translate that. So environment variables are great. They work, with Unix processes. This is just kind of extending it. And Spring already has this thing called an environment abstraction, so we're just plugging into that. There is a question. Are we planning on building a UI to sit on top of the configuration server? Somebody already built it. It's called GitHub.
It's true.
No, seriously, there are so many UIs for Git.
Great answer.
That I don't feel like I should write another one. I know what he means. He means for editing.
But GitHub does that.
GitHub does that. If you don't want to use GitHub, you can install it, GitLab. I've got lots of clients doing that. It's a great tool. George.
Josh, you can talk about how you deal with UAT environments versus non-environments.
Are we going to talk about how you change different environments using the config server? You could quickly show that. Actually, he made a mistake there because he did master. Did you see that master on the URL? That's actually the name of a Spring profile. Yeah. So he could have put UAA, UA as a profile name, test as a profile name.
How do you do that? How do you do that without changing the binary?
It's another.
That's the argument.
Yeah. Well, then you need an environment variable, right? So you need something that's going to change in each one. So what I would do is I would push to Cloud Foundry with env Spring Cloud profiles active equals UA, and then that would pick up the config from the right profile. Let's go.
We gotta go. I'm so sorry. Hold your question. We want the questions, but let's do it at the end because we haven't even started. Just the goal here is for you to leave with your eyes tearing, your hair on fire. This is not a gentle introduction. I want you to see the kitchen sink. I want you to understand what the destination is. Once you understand that, then you can go to the amazing deep dives later on with the good Dr. Syer and Mark Fisher on.
Yeah, that's worth mentioning. So
messaging.
Well, we haven't hit any of that stuff yet.
No,
but when we do, I'll mention it. Yeah.
The deep dives are later. This is 101. You got to see what the destination is, and you're going to want to go there. It's good. So I have this message value. I have this little value that I stood up as a REST service. I created this REST service like so. I said message REST controller. I injected the message from the property file on the config service. And I've just stood up an endpoint that will respond to /message. I want to change this message. This is a useless message. You're not the world. You're better. You're Spring 1. So we're going to go to the file system here. We're going to go to my desktop cd config service, or config repo. And I have files in there. So I'm going to say Joe reservation service.properties. And I'm going to change this file. Say hello Spring 1 command X. Okay. I'm going to say git commit -a -m YOLO, get status, okay? So I've changed it. I've got little droppings from my IDE there, but that's not the actual files. So there we are. We've made the change. If I go to the config server itself, the new value is immediately visible, right? But my old service, which injects that value, is not yet updated to reflect that. So one way to update it is to trigger a refresh. That's what that annotation is, @refresh. I can do this many different ways. One is just to use the local actuator endpoint called refresh on the node itself. Another way is to use Spring Cloud AMQP bus to connect different nodes via RabbitMQ. Either way, the effect is that you're telling the app instance to find all the beans that have this annotation, refresh scope, and to recreate the beans in situ, thus reevaluating the property from the config server. So let's do that, okay? curl -d, that's empty post, basically. Localhost 8000 / refresh, and then I get a sad face. What is that?
That's the wrong port. I think it was 8025, wasn't it?
Oh, but I threw that away.
Oh, you threw that away. Oh, because you're now on the config server, right?
Yeah. Did I just forget to add the actuator?
Yeah. Yeah, that's what you did.
Okay. Awkward. Spring.
Yeah, he was wrong.
I was wrong, as usual.
I think there was a time when he gave this demo, like in Spring Cloud 1.0.0 when it would have been, but somebody said, excuse me, why do we need the actuator for every config client? So we pulled it out. That would explain it.
Okay. Awkward. So let's do this one more time. Take 2. Okay. Updated. Nope.
No?
Haha.
Well, does it have actuator endpoints? Does it have mappings?
Yeah.
You should be able to see it.
Mappings.
No, right, so there's something else going on there.
This is the reservation.
Definitely restarted, did you?
Yeah. Maven. Re-import. Now's the time not to screw around, Mr. Application. There it is. So now,
Is there a refresh there? Let's hope.
let's go here again. Take 3. Third time is the charm, we hope.
Yeah.
Good. So instant,
Did you see it told you that he changed the message?
yeah.
It
Message.
was blink.
There we go.
If you were paying attention, you could
Okay.
see it, right?
You can applause. That's okay. I deserve it. I do. I do. No, actually, like I said, he wrote the code. I'm just dancing on stage. So moving on. That's one pattern, the centralized configuration. Second pattern, when you move to a Spring application, when you move to a cloud application, you're going to have lots of instances that live and die. They're ephemeral as capacity dictates, right? As capacity demands. So you want the ability to be decoupled from host names and ports. We talked about that in yesterday's epic keynote. What this implies is that I cannot rely on DNS. I need something to give me a bit of a decoupling. The way you do that is to use a service registry. It's a bit of a phone book. It's a way of saying, I want to talk to that service over there, and I know the name, but I don't know the host and port. The other benefit of this is that I can also do client-side load balancing. I no longer need to rely on DNS to know what kind of load balancing I'm supposed to do across services. So I'm going to go back to start.spring.io, and I'm going to build or stand up a Eureka registry using Eureka server here. It's going to be a config client as well. So again, what we're doing is we're standing up a service. I wouldn't do this normally. You can stand up Eureka easily like this, but then you have to set it up in a highly available way. You're going to normally have this running somewhere. You're not going to do it many times from here like I am. Or you might use...
PCF.
Sorry?
You might use Cloud Foundry to do it.
Yeah, Cloud Foundry has a very good service registry. You might also use...
I don't know.
Zookeeper?
Oh, one of those other things, right? Yeah. Yeah. Spencer's giving a talk this afternoon, I think, or is it tomorrow? Tomorrow, about all the new stuff in Spring Cloud. So if you've used 1.0 and you want to know what's in 1.1, then Spencer's giving a talk tomorrow about that.
I'll be there.
So that will include the new service discovery implementations.
So
Zookeeper, Console, Cloud Foundry, Lattice.
Generate Eureka server, open. Hello, computer. Eureka server, open this up. Same trick as before. I need to connect it to the config server and to the Eureka, and it's going to be, it has to identify itself. So I'll copy this bootstrap.properties. Here's application.properties. I'm going to paste in here bootstrap.properties. And we're going to say this is going to be named Eureka service. It is a Eureka service, and so I have to configure it as such. I'll say @enable Eureka server. And that should do. So I'm going to start it up, and it'll come up on port 8761, because that's what we have in the config server specified for it to do. So there's this. This is the Spring Eureka. This is based on Netflix's Eureka.
It's the same basic UI you saw last night in the demo, but that was the Cloud Foundry skinning for this. So this is running locally, and that was running in Cloud Foundry.
And that one was much more usable for a UI.
Yeah, and
I'm a big
it's
fan of
a
that
nice
one.
little, it's Ajax-y, so it responds when things change.
Right. So
Whereas
the goal
this one
here is
doesn't
to get
do that.
services to show up here, right? This is a phone book. Nothing is going to be able to find each other if they're not registered here. So let's go back to our reservation service. By the way, remember what I was talking about in the highly available mode? This is Eureka barfing all over the console saying, "Where's my peer? Where's another node for replication?" And it can't find one, so it's throwing up its hands in disgust, sheer disgust. It'll work, but this is a reminder that you should always configure this in a highly available fashion. So one instance does not a highly available Eureka instance or deployment make. Okay?
We tried to switch that off, but it's impossible.
Yeah, it really is. It's
It really
buried
is.
in the
They
code.
really want you to see that.
Yeah. So we've got that. Now let's go back to the reservation service and bring in the support for talking to the registry. Now remember, we have an abstraction here called the discovery client abstraction. It's common to all of these different service registry implementations. The things you're going to do with the discovery client, with the service registries, at the very minimum, you're going to ask questions of it. You're going to ask, where does this service live? Is it available? How do I talk to it? Sometimes you may also have to write to it. You may have to say, if you need me, I'm here, right? That's optional. So for example, Cloud Foundry, or Lattice, these are both platforms. They already know where the service has been stood up. You don't need to tell it, right? So our discovery client implementations are read-only in that case. But naturally, Eureka and Consul and Zookeeper, they need a little bit more hand-holding. So in that case, they both register and read from it. Okay, so I've got that up and running. If I go to here, there you see, there's our service registered in the Eureka registry. There's one instance, it's running, it's up, and it's on this host name. I now need to write a client. I want to build our first client, something to talk to it. So reservation service, reservation client. Okay, Doc, what do we need? Eureka discovery, Eureka, a config client.
You were going to don't do the security, because I don't think it's going to work.
Sorry?
Don't do the security.
No, okay, we won't bother. These are milestones, friends.
You're going to do zipkin eventually?
Yes,
Be
thank
nice
you
to
for
see
reminding me. Redis.
Stream, yeah. Mark and I are doing a talk on Spring Cloud Stream this afternoon. Come to that if you want to know more,
amazing.
but we'll see it really quickly now.
Anything else? I'm going shopping. It's always nice to have everything you want in one basket, but okay, here we go. Reservation, client, open. Whew. Now the goal here is we're going to build an application that talks to our microservice, and it's going to discover the microservice through the registry. This is going to be a client, first of all, but it's also going to be an edge service, something that'll sit at the edge of your data center and be exposed to other services, right? So, other clients rather, things like iPads and iPhones and HTML5 browsers and so on. So, we're going to build an API. What we want to do is first connect this to the registry, and we want it to get the configuration. So I'll say enable discovery client, just as we did before. And I'll change the resources or application.properties into bootstrap.properties. Rename it, so it'll be called reservation client. Now, I want to build a client that talks to these other services. The reason you do this is because you have different kinds of actual clients that will talk to these mid-tier services. It's nice to have an intermediary, an edge service like this that sits between your iPhones, your iPads, and so on, and the mid-tier services like our reservation service. Netflix does this. Netflix have 600 different microservices. They don't want to have to update each microservice whenever a new client with protocol-specific requirements or security requirements or API granularity requirements are introduced. Like if there's a new iPad, they don't want to have to update each of those 600 microservices. So instead, they build something in the middle. And this is called an edge service. There's a couple of different kinds of edge services. One is a microproxy. Imagine, for example, an HTML5 application. HTML5 has cross-origin request forgery limitations. You can't make requests that run afoul of this security model. So it has to be the same host, same domain. Sure, you could go to each one of those 600 microservices and add a policy that permits cross-origin requests to those services, but that would be tedious and it would require a crazy amount of work, right? Especially considering it's just one actual client. So it's instead better to have a proxy that sits in between. We're going to use Zool. Now, if you are up on your Ghostbusters mythology, you know that Zool is the gatekeeper, okay? Isn't that adorable? So cute. That's the monster that guards the underworld, okay?
It's in your fridge.
Yeah.
I've seen a few of those in my fridge.
So we're going to use @enable Zool proxy. And that may be enough. All this is going to do is it's going to stand up a proxy that connects to the service registry and forwards requests to the services available in that registry. So in our case, let's see what happens. If I go to demo application, I just run it. We should see something. This might be enough. Again, if you're using HTML5 and you've got this requirement, add this annotation, figure out why it blew up. What did I do? What did I do? Conditional. Oh, did I not see? We didn't do the Zool starter.
We didn't, no.
Awkward.
I did that, yeah. I thought you didn't. And I thought, maybe he did.
Didn't I?
No, you didn't. I didn't see you click it in the initializer.
Awkward.
It's all right.
Okay. So if you have an HTML5 application, maybe all you need to do is forward requests from the client to the mid-tier services. You add SSL. You add some sort of security, maybe HTTP basic or OAuth or something, and then you're done. Maybe that's enough. Maybe you don't mind making multiple chatty requests from the client, the HTML5 browser, to these mid-tier services, and you're not really trying to optimize for bandwidth because it's a desktop 5 browser or whatever, you know. So I can go here, I'll say 8050 reservation service / reservations. And it'll sort of not work. What happened now? Oh, Zipkin. Adrian. So we're going to reintroduce this later. In the meantime, I'm going to curse under my breath. You can't hear that, right? What it's going to do is it's going to stand up a proxy that'll forward all requests to the service that's specified here in the context path, right? So 8050 / reservation service / reservations. There we go. Jeez. So there's the data coming from the reservation service on another node, right? So
look at the links. Look at the links. Look at the address in the links.
Sorry?
8050, right?
Yeah, 8050 versus 8000. And notice that the context path isn't there. So this is the actual service, the original one. But it's registered in the service registry under the name reservation service. So any request that goes to / reservation services / gets forwarded, naturally, to the service in the registry. Maybe that's enough, you know, but that would be a lousy demo, and we can't really stop here, so it's not enough, obviously. Another use case for an edge service is a API gateway, right? This is a micro proxy, but maybe I want to do API translation. I want to take the payloads that are being returned from the client and transform them. Maybe give a client-specific payload that is more appropriate, or you know, whatever your use case is. So I'm going to build.
There's Bill Gorder in the room.
What?
Can't see. Bill was asking me last night about this problem.
There you go. So we're going to build a service, or another REST controller, that will talk to our reservation service. But it's going to do some basic translation.
We're back in the client now, right?
Yeah, reservation client. And it's going to be called reservation API gateway REST controller. I am nothing if not succinct.
We need a factory or something, right?
Yeah. So I'll say reservation. No, what I'm going to say is I want to inject a REST template because I want to create a REST service that returns the reservation names. I don't want to return all of the reservation data itself, just the names from that collection of reservation objects. I'm going to map from reservation to the reservation name in the reservation. Just a simple, nonsensically trivial mapping, but it's a useful exercise, okay? So when I do this, I'm going to use the injected REST template, right? Does this need to be load balanced? Yeah.
No, yeah. Oh, yeah, does it? I don't know.
So that's load. I'm going to make it load balanced, and what that's going to do is it's going to let me make calls and have them load balanced automatically by a component called ribbon, and we'll talk about that in a second. So I'm going to say this.resttemplate.exchange http://reservation-service/reservation. So again, this is not DNS. This is the service ID as it was registered in Eureka.
I'd be surprised if there was, just to underline that point, I'd be surprised at this point if there was any other REST template in the context, but what he just did was add @load balance, which is an @qualifier. That's an old Spring 2.5 feature, isn't it? 2.5? Something
Right.
like that. So we're saying we want a REST template, but not any old REST template. We want the one that's
Load balanced. It's documentational, if nothing else. I don't think it'll hurt. So we're gonna tell the REST template to make this request and to pick from all the registered instances one node to make the request to. This is going to be done by something called Ribbon, which is a software-defined load balancer. It's going to, in software, in the client, pick the instance and then route the request. By default, you'll get round-robin load balancing. But I might want something like multi-tenancy. I might want availability zone awareness. I might, whatever that use case is, I want the ability to evolve and make that decision in the client. It's much easier to do so than at your big 5 router layer, for example.
Latency is the big poster child.
Yep,
Pick the least latent route.
Yeah, exactly. If you have a sick service behind the load balancer, and you can't tell, right? There's no way to ask that question now. So having that logic in the client is a very, very powerful thing. So I need to tell the REST template that I want a list of the hypermedia data that's coming from the reservation service. I'm going to create a client-side DTO just to store the data. So private long ID, private string, reservation name. Now,
which looks surprisingly like the server-side one.
Right, yes, very, very, very true.
But
now,
that's only because you've got a really simple domain, right?
Yeah.
Normally it would be probably a bit different.
Nonsensically trivial.
Yeah.
The reason I want a client-side DTO is because in theory, and again, this is just a theory, nobody's ever proven to my satisfaction that it actually happens or that it will happen to somebody who's sane. But in theory, the client and the service could be written in some other technology besides Spring and Java. Now, that's a theory. It's not actually going to happen. But if it does, then you want to be decoupled from the types on the class path in the service, right? So client-side proxy is what we can use to map, okay? Now, I'm going to tell the REST template that I want exactly that result. I'm going to say parameterized type reference of resources. This is the Spring hypermedia envelope type from our REST API. And it's a common type, so we don't have any hesitation in adding it, okay? I'm going to use resources like this, or not. Try again. There we are. Just took a second, didn't it? You're all right, Maven. You're all right. Now, it's now appropriate to spend a minute and reflect upon the fact that Java doesn't really type. So it has what it calls charitably a type system, but the type system is kind of broken with respect to generics. The generics aren't reified. That is, at runtime, there's no way to ask an instance variable with a generic parameter what its instance type is, a collection of T. What is T? That information is lost at runtime thanks to type erasure. You can capture that by having a subclass. You can say class X extends array list, for example, string like that. And then you say list of string X equals new X. And at runtime, if I ask using reflection what its type is, it'll tell me it's string because I've baked it into this hierarchy here. But if I had just a regular array list, that would not work. So what we're going to use is a type token pattern to create an anonymous subclass which captures that generic information. That's what this is. This doesn't compile if I omit that. Okay?
How many people use that already? It's just a Spring web feature, right? Nothing.
I'm a fan.
Nothing all that new about it.
It's pretty all right.
As soon as we had to deal with generics and REST template, we had to have that.
Yeah. So there we go. So I'm going to pass that little PTR into this, and that'll tell the REST template to give me a payload that I can use. Here we go. And now I can iterate. I can return the data. I'm going to say return response entity dot get body. Hold your breath. Get collection, stream, map, reservation, get hey. Dot collect, collectors, dot to list. Okay. There we are. So now I've got this. Now, when do we officially wrap up, by the way?
An hour and a half, isn't it? So 12.
Oh, good. So look at the
We've
clock.
got time.
Okay, so now I've got a REST service that's going to return a collection of names, and I'm going to map that to an endpoint here, /names, like so. And this is going to be a REST controller that will map to /reservation. So this is the client side. This is the edge service that's talking to the mid-tier service that's in the registry, and it's going to return just a subset of the data there. So I'll restart that, and we should be able to verify that that works. Okay. Okay, here we go. This is the micro proxy. Now I'm going to say reservations /names. There's the data. Okay, so we have the data just as a collection of JSON strings, not actual JSON objects. So that works. That's okay. We're able to read the data. But what if I want to make changes? I want to write to the data. You know, when we have a distributed system,
Right.
You want to do state synchronization. And some people say, all too quickly, I think, let's just be clear here, that we could use distributed transactions. We can use JTA. That's no way to run a railroad, friends. That's a terrible idea. A terrible idea. Now, Spring.
So what are you going to do instead?
Well, we're going to use messaging. I want to spend a second on the JTA thing, though,
Ah.
because, see, it's a checkbox, and I really want to discourage people from moving to a distributed world and then bringing the house down with distributed transactions. Spring Boot readily supports JTA. It supports distributed transactions
Yeah,
using this, for
but
example.
that bit of code was written by, I don't know,
There's some idiot wrote this code, and I don't approve of what he has done. Now, why? Okay? I know what I'm talking about. Don't use it. Just, you don't want JTA, you know. Once you know how sausage and distributed transactions are made, well, I might still have the sausage. Anyway. So, let's use messaging, right? What do you think?
Yeah, why not? Yeah, it's like CQRS or something, isn't it?
Yeah, exactly. I want to optimize for consistent writes. I want speed in my writes, but I want to make sure that they eventually get written. So I want eventual consistency.
So we read using HTTP.
Right,
Simple, like we've done that. And then we're going to write using a post that forwards to a message.
Right, so that implies messaging.
Mm-hmm.
And in a new feature in Spring Cloud 1.1, or Brixton, or what's the right name?
Brixton is the release train.
The release train. A new feature in the new version of Spring Cloud is that we have the concept of a release train. Another new feature in the new release of Spring
Cloud Stream 1.0.
Right. Yeah.
There's something you can learn about in gory detail with me and Mark this afternoon, but we're just going to quickly show how it works here.
It's going to be amazing. So let's do another endpoint. We're going to create another endpoint that will respond to posts, okay? Post, like so. And I'll say public void write. And I'll say request body reservation R. And I need to make a call to this. So once we do this, we need to make sure we do Hystrix. So I'm going to make a call.
All right.
To my messaging bus. In this case, I'm going to use Redis, but we could as easily use Kafka and RabbitMQ, right?
It's Redis because you included a dependency right at the beginning, right? Is it still commented out?
Spring Cloud Starter Stream Redis.
Still there. Okay.
It's going to auto-wire the connections between these different services. So I can just include them, and I bind them. I use the @enable binding annotation. So I'm going to go up here to my application, and I'll say that this is going to be, oh, hello, @enable binding source.class. Okay, source.class comes from org Spring Framework Cloud Stream Messaging Source. It's an interface that by convention defines a channel that has a name called output. Okay, so output. What we're doing is by configuration, we're mapping inputs and outputs, egress and ingress channels or destinations in your different services and giving them a named conduit, a pipe. And so that configuration lives in a config server here, right? So where's the config server? Here we are, reservation client. And you can see that we've said Spring Cloud Stream bindings that output equals reservations. On the other side, I'm going to have blah, 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 dot input equals reservations. So they're going to agree to meet, have a rendezvous at reservations.
It's kind of service discovery by middleware, right? The messaging middleware. So there's going to be a message queue in Redis, or Rabbit, or Kafka, depending on what you want to use, called something, something, something reservations. You don't care what the something, something, something is. That's the beauty of it, right? So all we did is add an annotation, and it's going to set up all of the queues and infrastructure in the background.
So we're going to inject the message channel there. This is a Spring messaging type. It comes from Spring integration. It's now part of the Spring framework. You also use this when you're dealing with WebSockets, for example, and indeed the larger Spring integration technology. And what we're saying is I want this named conduit. It boils down more or less to a java.util.q behind the scenes by default. But we're going to connect it to middleware integration adapters that'll speak to, for example, Redis or to Kafka or whatever. And that happens automatically. So you don't have to really wire that stuff together. You just inject the client or the pipe here, and you put something in. So I'm going to say this.messagechannel.send message builder dot with payload, and I'm going to say r.getReservationName dot build, okay? And that's me sending a message for somebody else to consume, and I'm going to use that to asynchronously receive the reservation name and then write it, okay? That look okay to you, Doc?
Yeah.
Okay,
You're going to show the Redis CLI so we can actually see the
Okay.
messages.
I should do that, and I'm going to go also to the service itself and do the reverse. I'm going to accept new messages on the service. So
Okay.
here, I've done the same thing. I've got Spring Cloud starter stream Redis. I'll bring that back into play. Here we are. And I'm going to do the @enable binding in reverse. I'll say I'm going to be a sync. No, yeah, sync.
Yeah, you were a source on the other side, so you're a sync on this side.
In sources beginning.
If
sync
you
is
don't
out.
like those names, if they confuse you, which they will,
Yeah.
you can make up your own interfaces, call them whatever you want.
Yeah, in and out, for example,
Yeah.
or output. And with that in place, I can create a messaging endpoint, message endpoint. This is a Spring integration type, class, message, reservation, receive, I before E, you're English, how do you spell?
I before E, except after C.
Well, E-I-V-E-R, this screws with my dyslexia. Okay, public, void, accept, reservation string rn, oops, okay. And I'm going to make this a service activator. That is to say that it's going to be called whenever a message comes in. It's inversion of control for messaging. The Hollywood principle, don't call me, I'll call you, right? So input channel equals sync dot input. And I'm going to inject the repository that we had here on the service, the reservation repository for Spring Data JPA. And I'll just use that to write the data out. Okay, so this, the reservation repository dot save new reservation rn. Okay. If I go to the other side, I need to make sure that I did that correctly. Good. So that looks legit. Let's try that. So we're going to go back to the reservation service, restart, go back to the reservation client, restart as well. Excusez-moi. Dégueulasse. Okay, and that'll do, I think. That'll, fingers crossed. We're going to go to the console here, open this up, advanced REST client, and I'm going to send an HTTP post to this endpoint. And it's going to have, we've already got him. We need somebody else. Who wants to play? Hi. Name?
K-Stack.
How do you spell that, buddy?
K-S-T-E-F-F.
K-S-T-E-F-F. Yeah? Cool. I think that'll work. You're going to be our first victim. So we're going to post to the API gateway at /reservations a JSON document of type application JSON. We should hit, and if it works, we should be able to see this reflected here. So I'll do that. Let's get this out here. Okay. And here. Ready. There we are. Good stuff. So messaging is working, right? We're able to read with REST, but guarantee writes with messaging. CQRS, we're optimizing for the right kind of read and write, and we're separating them, so we don't use the same for both. Naturally, this isn't the same as a distributed transaction, but you do get state synchronization, and it is guaranteed to work eventually, right? Eventual consistency. Okay, well, I wanna make sure that if something does happen to one of my reservation services, for example, if the instances should go down, that we recover gracefully. Remember, in a sufficiently distributed system, there is no such thing as 100% highly available, software. Instead, you want to optimize for time to remediation. How quickly can I recover? And can I be graceful when things are down? That's what this is all about, is being graceful when things happen. So I'm going to go back to my reservation client here, And I see here that if I make this call using the REST template, it's going to do load balancing, and that'll work for 1 to n instances, right? But it won't work for 0. If there are no instances registered, this is going to blow chunks. Things are going to go south, and the iPhone will get a stack trace sent back to him, or maybe an ASCII artwork for the middle finger, or something just unpleasant, you know? So we need to have some sort of, we want to isolate that failure. We want to prevent it from cascading beyond this little limited place. We're going to use a circuit breaker, which, as you know, in a building, is meant to guard that a failure, an oversurge of electricity, doesn't cause an explosion and a fire, which then takes the house down. I'd much rather the circuit breaker open and the lights go off than to lose the house for a fire, right? So that's what we're going to do, is we're going to introduce the circuit breaker pattern here using a component from Netflix called Hystrix. I'll say @enable circuit breaker. And then I'll annotate my method here. I'll say @Hystrix command fallback method equals, and I'll pass in a method name here, fallback. And all I'm going to do is I'm going to return just something simple. I just want to have a useful fallback scenario, graceful degradation, right? Netflix and other big services, they do this all the time. They'll say, oh, well, this service isn't available, but here's something else. So in this case, it'll just return an empty list. Okay, so this is my reservation client. I've got the, I should have that on the class path, maybe. Okay. Looks okay. So if I go to the names endpoint, again, things are happy so long as the reservation service is there. But what happens if I now go to the reservation service and, take it out of the game, like so? Immediately falls back to the empty array list, right? Resiliency is a feature, my friend. So okay, I'm going to bring back the reservation service. That's one feature. I want resiliency. I also want, when something goes wrong, to be able to see what's happening. So
You're going to show the dashboard.
we need to do the dashboard, and we also want to do tracing.
Yeah, let's get to that. Let's
Okay.
get to that.
So
Yeah, okay.
service, do we have enough time?
Yeah, we've got time. I was thinking we might even be able to do the SSO at the end, because I think that there's something about your GitHub account that isn't working, because I tried it here and it's fine.
You sure?
So, I don't know. Well, let's see how far we get.
Can we edit the...
Let's see how far we get, and we'll have a vote.
Okay, we'll edit the video if it doesn't work.
Yeah, this bit's coming out of YouTube.
Okay, service is back up. Things should be healthy. This will eventually recover. It takes, 30 seconds, something like that. I want to visualize what's happening. So again, if you're building cloud-native software, here we've got software that is resilient to failure. If you have a platform that's underneath you that's babysitting your instances, it's going to heal the application. It'll see that you've got a failed instance, and it'll recover. It'll restore the state so that if you asked for 5 instances or 4, as the amazing Scott Frederick did yesterday in the keynote, you will get 4, come heck or high water, right? I don't have that platform running on my local machine here, but I just restarted it manually. So it's going to recover. That's good. That's important. You want the platform to wear the pager for you, and you want your software to play nicely when that happens. I do want the ability to visualize what's happening, though. I want to be able to see, where these circuits are where there are trouble, where there's trouble, right? So I'm going to go to start.spring.io, and I'll create the Hystrix dashboard. Here we are. And the Hystrix dashboard is it's just that. It's a dashboard that you can use to visualize the flow of traffic through circuits in your system. I'm going to be using the config client, naturally, and Eureka discovery, and Hystrix dashboard. Voila. And that'll do. Here we go. Generate. Show in Finder. Open. And this is a very simple app. In fact, it's almost artfully so. So paste that in there. We're going to name it Hystrix dashboard, because I can. And I'll remove application.properties. And I'm going to go to demo application, and I'll say @enable Hystrix dashboard. Okay? And we go. Now this will come up on some port. I have no idea, literally no idea where we are now. Port, somebody? 8010, I'll buy that. Localhost 8010/Hystrix.html, okay? Now, Hystrix.html, this is a dashboard that expects a stream of information from these circuit breakers. You're going to have circuit breakers throughout your system, and they will emit a heartbeat, a service and event stream that you can get to from the node localhost 8050/Hystrix.stream, okay? This is server send event, so don't try curling this. You'll be there for a long time. You want to paste that into here, and you can monitor, right? And you can see this pretty visualization of your circuit. Remember, my circuit is the REST controller called get reservation names. I'm going to now move that over here, move this over there, and let's create some traffic, and we'll see what happens when I create some activity. If I could just find an instance. Oh, here. Reservation names. Good, so I'm going to drive traffic on the left. I'm command Ring it as fast as my little fingers will let me. And you'll see that the visualization on the right is more or less real time. I'm going to let go now, and it's still refreshing. That's how hard I wailed on that. And you see it's bursting. So it's real time, but it's a moving average. As traffic drains off, the numbers trend downward again. Great, so things are green, things are good. Green is good, spring is green, spring is good. Let's see what happens if something goes south, okay? Go back to reservation service. Take it out of the game again. Sad. But now, instant, it's red on the right, 100% failure rate. And eventually that circuit will be officially opened. And you can see that that is happening, right? You get the ability to visualize the flow of data through a system. This is just one service, right? So I'm going to restart my reservation service, and we'll come.
Did everybody get that?
Sorry?
when the circuit is open, it went blue. Did everybody see that? So red is a failure. Blue is, I'm not even going to try.
Yeah.
Right? I know it's down. I'm not even going to try.
Yep.
And that's what's useful about it, right? That's why it's a circuit.
And now, of
not
course, it
even
healed,
trying.
and things are good again.
So we cut off the downstream traffic completely so that we're not going to overwhelm anybody further downstream.
Exactly the point. Yeah, you want to prevent the failure from becoming more than you can handle.
More than just you.
I did that for a single node. Naturally, if I have more than one service that uses a circuit breaker, I want to visualize and aggregate. For that, we have the turbine AMQP checkbox here. It connects to RabbitMQ and then aggregates these streams from across different circuits and different systems into one stream.
Yeah. They don't do that at Netflix. At Netflix, they just they ask Eureka where all of the service instances are, and then they go and pull the streams from them. But we did it the other way around. We push them to AMQP. So there's just one place where you just listen to a messaging queue and get all of the streams in one place. And that's what that turbine AMQP is. All right, tracing?
Tracing. Now, this is another really exciting feature inside of Spring Cloud Brixton. Where do you live, by the way? Which city?
I live in Brixton.
Oh, wonder what happened there.
I wonder why it was called that.
What a coincidence. Of all the permutations of letters in the known world. Anyway.
Well, if anybody else has a favorite tube station beginning with C, come and talk to me later.
One of the exciting new features in Spring Cloud Brixton. I did it.
Well done.
Well done. Thank you.
Get used to it.
One of the exciting new features here is an integration of something called Spring Cloud Sleuth.
Sleuth. Who knows what a sleuth is?
Like Sherlock Holmes, exactly, a detective.
Right,
Somebody
yeah.
finds
We've chosen this name, somewhat controversially, it has to be said, but so many people said, yeah, I like that, I really like that. We couldn't change it. Apparently it's very difficult for Chinese people, sorry.
Yeah.
We're going to have to find a nice Chinese character to put on the website that means the same thing.
We didn't mean some words are just unpronounceable, and for everybody, right? We all have words we can't get across, so.
Yeah, my 5-year-old has trouble with salute, actually.
Yeah. Awkward. So anyway. We want to integrate this. What it does is it provides us distributed tracing.
Why would you want that?
Well, if I had more than one service in a distributed system, which, well, I will, I want to be able to correlate which request triggered some sort of output in another service. If I make a call from one service to another, and the middle one dies, I want to see which request from the first one triggered the error in the second one. I need to correlate.
It's about relationships.
It is.
And it's a little bit about latency as well. People use this for hunting latency bugs.
Very good, very useful. So we have, it's a generic abstraction, Spring Cloud Sleuth. There is the first implementation is based on Zipkin, which is from...
Actually, second implementation, but anyway, yeah.
Awkward.
First implementation is just logging. Everything goes to standard out, and then you can aggregate it any way you want, which is actually pretty powerful.
Yeah.
And we have clients already using that, because that was a contribution, right? That came from the 4 finance guys.
Right.
Hi, Martin.
Thank you if you guys are here.
Thank you. And then we added an abstraction and implemented the abstraction for this Zipkin thing, which is Adrian Cole's baby. Adrian joined us recently. You might have seen that on Twitter. He'll be here later on today, so if you want to talk to anybody about tracing, the guy who basically wrote the book on it is going to be here later on today. So he just joined us from Twitter.
Yep. And he was at Netflix before that. And
He was at Netflix, he was at
Yep.
Square, he was pretty much at any
He gets around.
yeah.
The guy can cloud.
Name a big internet company. He was there.
So now, we've got this service, and I want it to be traced. So I want messages that go to it to be
I can
traced.
already see trace
Oh yeah,
on the logs there.
I've got a log formatter. These are empty at the moment, but I want to turn them into the actual correlated,
They're empty
traceability.
because nothing's happened, right?
Right.
You're just logging the startup. That's the, like the main
Exactly.
thread. Yeah.
So first thing I'm going to do is I'm going to go back to my build here and reintroduce Spring Cloud Starter Zipkin. And I need to introduce a sampler, a bean of type sampler. Now, why would I want a specific type of sampler, Doctor?
Because it's in the nature of these distributed tracing systems. People find, surprisingly, that there's quite a lot of data that you could generate with this kind of thing. So it's actually completely mandatory to have some kind of statistical sample. You don't want to collect all the traffic. It's impossible. It just kills any backend that you're ever going to put on it. So there's a thing called the sampler that we introduced as an abstraction in Spring Cloud, which basically just, at the minute, there's only one implementation. Two, there's one that says always and one that says never, and never is the default. And so we just put an always in so that we're going to get all the traffic. But you could add one. We will be adding more. So we'll be adding ones that you can tune at runtime, right? So you can say, right, I want to sample all the requests from Starbucks man because he's an idiot and I want to see what he's doing.
Absolutely.
That kind of thing.
That hurt.
But at the minute, we're just going to get all the traces for all the data so that we can have a look at something.
Run. Stop and rerun. Run.
This will be in the keynote tonight as well, by the way. So
Don't
keep
give away.
your eyes peeled. Oh, you can say, tell the person that you're sitting next to that you were the privileged viewer of the first demo.
And is there a talk at length on this, or a more detailed talk?
I think Spencer will be going into it in his talk tomorrow.
Okay, good. Perfect. So, what have I done? I've added the always sampler to both the reservation service and the client. I added Spring Cloud Starter Zipkin.
Oh, actually, and me and Spencer this afternoon as well. We're going to
There
do
you
some
go.
Zipkin.
So there you go. So that's on both sides. Now I can demonstrate this by going to the reservation client, getting the data, right? There's the request, and I can
client
also
got a REST request, and he went off to the service with another REST request, right?
right.
So we're expecting to see two spans, two elements of that request.
Two legs on the journey.
Yeah.
I have Zipkin running on the shell here, and another node. There's three processes. There's the web, the collector, and the query engine. So these are three things running on the side. It's pretty easy to run. Just git clone the code and then go into the bin directory. It's a Gradle build, so you can just do bin/collector, bin/.
There are Docker images, actually.
Yeah.
That's probably
Docker's even easier for
yeah.
that. Okay, now, let's see. If I go to localhost 8080, which is where Zipkin is running its web UI, I see this, okay? And you can see it's got instances, services for both my client and my service. They're both here. And specific types of circuit, or specific types of traces, specific ingress and egress points in the application are represented here. So reservation names, I want to see everything from there to there, and this is about a minute ago, right? You can see that I have a reservation service. Well, here, Doc, you explain.
Yeah, what are we looking at? So, yeah, the call came in, it's like a waterfall, right? It's a graph with a timeline in it. The call came in at the top I can see the path there, /names. Something happened, a little bit of latency there. It took almost 60 milliseconds before the server on the other side got it. All right, so you can see that span starting. If you click on that top one, Josh,
Yes, sir.
then you can see there's some duplication going on. I'm not sure why that is. We need to sort that out. But look at the top there. You can see client send, client receive, bracketed around server receive, server send. And so the server has sent back some data to this span to say that it got the data and it dealt with it and it sent it back again. So you see a timeline. The terminology here is actually from Dapper, which is the Google tracing engine that isn't open source, but they publish a paper on it. That's the way they do it. They're Google, right?
Netflix.
No, it's
Okay.
Google. Everybody uses something a bit like Dapper. So Zipkin is Dapper-like. There's another thing called htrace, which is on in the Hadoop ecosystem, which is it's got a slightly different data model, but basically it's Dapper-based. The problem with Dapper is that it's very RPC focused. So it's all about clients sending and receiving and service telling you that they've finished with it.
Speaking of sending, let's also see what happens if I use.
Yeah, let's do a messaging one.
Right.
Cool.
So
yeah, what do you think is going to happen?
Who's already in our? We need another name naturally. So, Josh, all the community, Jürgen, Dr. Syer, Dr. Rod.
Peter. Peter with an I.
Gary, my boy, Gary. Okay, so Gary.
Yeah.
There we go. Hit send. There's Gary, right? So that worked.
Okay.
Now we go to Zipkin. This one bug doesn't support the escape button. Okay. What do we see now? We see that if I
The
do
UI
file,
is what they use at Twitter, by the way.
sorry?
The UI is what they use at Twitter.
Yeah.
They don't
Newest
like it,
first.
so-
Reservation client. No.
You want the one that you just posted, right?
Yeah. Well. Okay. So to reservations, find traces. Less than a minute ago, I think that one qualifies.
There you go.
Yeah, HTTP reservations. So this is where we posted the message. You can see the headers here at the when the data came into the system. And then you go down here and you see message input. That's the other side where the messages came in from Redis. You would see the same kind of messages from RabbitMQ or Kafka, header information, metadata about the transit.
There's a little bit of latency in there. Can you see that if you go back to that screen behind?
Yep. Worth noting is that we're doing all this automatically for you. It's interceptors on the REST template, on the Rabbit template, all that stuff on the
Yeah,
message
that's the
channel.
important thing, right? I didn't need to do anything to change my code. All I did was add a sampler, right? Look at the latency. You can see when the post ended at that little blip, the white blip, and then there's a gap of like a few milliseconds where Redis accepted the message and then pushed it off to the...
So this is message broker time.
That's message broker latency there that we can't actually capture yet, at least anyway with Zipkin.
But you can infer interesting things.
Somebody had a question. Where was that?
Yeah, you, miss.
Yeah, you go first. That's fine. In the log, so what is the correlation ID is the question, is the first question. Can I deal with that one first? Yeah, so if you look in the log, you will see some UUIDs coming up in the log. And so there's a trace which is global across the whole of that waterfall, and then each of those bars is a span, and a span has another UUID. What was the second question? Yeah. Yeah, so the question is, if there was more than one hop in this conversation, what would happen? Come to the keynote.
Yeah.
And we're going to do that tonight.
So-
Yeah, I mean, obviously, we have to just pass all you have to do really, essentially, is keep the trace ID and send it in headers to the next guy. And if he's listening in the right way, then he'll pick it up and turn it into more information.
I have a
Yeah,
question.
behind
Wait,
you. What?
we're nearing.
You're asking me a question.
Well, we were almost out of time.
Are we? Right, okay.
So before we take more questions, first of all, what do you guys think, guys and gals? Yes, no, maybe? Amazing. Would you use such a beautiful thing? Can you see the use cases for it? Absolutely. So be sure to check out the balance of the day and the balance of the show. Lots of great talks on this, of course. And the
Yeah,
cloud track.
I'm trying to enumerate them all. Spencer and I are talking this afternoon on developer experience, specifically with this stuff. Mark and I are talking this afternoon about Spring Cloud Stream, all the messaging. We'll have Zipkin in the first one. There's a keynote tonight, which has got a demo. I think Michael Minella is talking about Spring Cloud data stuff, batch stuff. Marius is talking about Spring Cloud Stream data flow, Spring XD evolution.
Yeah.
There's all sorts of stuff happening. Watch out for those in this track and also in the big data track mainly.
I wanted to say thank you very much.
We can have another question.
Well, thank you very much, okay? Just, that's all before you go.